Good morning and welcome back. We're here with LiveCTF Day 2. I'm Mark.
I'm Josh.
And we're bringing to you the first of Day 2 here. We've got 2 matches head-to-head going on behind this wall. Speed match. We're looking at, we're going to have Undefined versus Blue Water on screen, and then we're going to have
Super Dice Code versus Norse Code off screen.
Yeah,
now we're in the lower bracket here. Sorry to cut you off. But we're in lower bracket here. So a team that loses this is out. They're out of the entire bracket.
Yeah, a lot of pressure is on. But we've got a good challenge cooked up for them, and I think we're ready to start.
I think we're good to go, except our production team is now turned into ghosts or are hiding. But we're good to go.
We're good to go, so let's count it down.
Yeah, together?
Yeah.
5, 4, 3, 2, 1. Let's go.
All right, and bear with us here as we figure out.
And then, boop.
There we go. All right, and so we're watching Undefined first.
All right, Undefined.
And so this challenge is called Jammer, and this is a special one because it's another throwback challenge to a time when things were a bit simpler, you know?
Oh, better times.
Yeah, really the golden age for vulnerabilities. But this is a stack buffer overflow. Ooh,
First Ghidra.
Yeah, I think someone noted in the comments yesterday that it was 7 out of 8 teams that they watched had IDA and 1 Ghidra user. So I really like to see the variety.
Yeah, we're starting off with IDA versus Ghidra, battle of the second and third best reverse engineering tools.
Yep. You know, I'm a Binary Ninja fan myself, but
I'm a Binary Ninja dev myself.
Yeah, people use what they're used to, and they're definitely all going to be sufficient
Absolutely.
for this kind
the
of work.
best tool is the one you can use effectively.
Exactly, and people do get really good at using their favorite. So let's.
So, okay, we see, again, 2 different approaches here. We see Undefined going with, that's us. Here, Team 2 overlay. All right, so we see Undefined. They started out a little bit doing, whatchamacallit, dynamic analysis, just interacting with the program, seeing what it looks like, and now they're hopping back into Ghidra, trying to figure out where interaction starts, where they can go. What is this challenge? You wrote this challenge.
Right. Well, yes, I did. This is, as I said, a throwback challenge. This is a challenge that was originally written for the DARPA Cyber Grand Challenge in 2016.
Really?
Yes. So it's a rematch of a rematch challenge, really.
Nice.
And so shout out to Debbie Nuttall, who was the original author of the challenge, and I lightly modified it so it would fit for our scope here. But it is a throwback to a bug from 2002. If you remember the SQL Slammer worm.
Slammer worm. No, I don't think I was around for that one.
Yeah. So in 2003 is when SQL Slammer was taken over the internet. And so this is a stack-based buffer overflow, a classic stir copy. And so I think here what we're really going to be looking for is how fast can they find that?
Slammer Jammer. I just got I like it.
Yep.
Okay.
We're very clever here.
So I was the one that verified this challenge. So I can say going from 0 knowledge to a full solution on this challenge, it was pretty clean. You know, you figure out interaction flow with the program, and then you start building an idea of what to do, I want to say. Like, you're not lost in the sauce.
Yeah, and it is, you know, a simplified challenge. The DARPA Cyber Grand Challenge was built to be, these challenges were built to be analyzed by automated competitors, which I think is funny, because it's like the biggest data set ever produced to be looked at by machines, right? And so let's see how fast our competitors can figure this one out. So let's switch over. And look at Blue Water here.
All right, so they're going through. Now this binary isn't stripped, is it?
No.
Okay, so they have some symbols to work with in the beginning. So they're going through, they're annotating different structs, and they're kind of figuring out, okay, so they're building a struct just called instance, and I think that's returned by create instance. So the names of these functions really do help you out with your first initial look around.
Yeah, and so what's interesting with this is that we're actually seeing both competitors digging into the structs right away. And this is an interesting one because there's a decent bit here, but actually the vulnerability itself doesn't require any knowledge of the structure.
Really? Oh, you're right.
It's just a stack-based stir copy. So a classic bug, very simple. And really the challenge here, because it's a speed race, is who can find it and exploit it faster.
So this is kind of a reverse engineering pwn challenge. Like, you need to find the right area first, obviously recognize the bug.
Yeah.
But then, you know, popping a shell after that is, these guys should be used to it.
Right, right. And so that's one of the things that I enjoy about this challenge in particular with the speed challenges is you just have to win first. And so one strategy, which I'm not seeing either competitor do, is to look at the key functions that might be the fast win functions. So you can see a reference on Blue Water's screen here. On the left-hand side, you see the list of imports, and you see stir copy there. And stir copy can be innocuous.
Yeah, but you see a stern copy and a stir copy. I kind of raise an eyebrow at that, and I'm like, the author left this in.
That's true, and especially whenever you're dealing with strings and C code, you have to be careful. And so you want to. It's always reasonable to take a quick peek at those and see where it gets used.
Oh yeah, for as much flack as I give Go, they do strings better.
I think C sets a pretty low bar.
Yeah, maybe. What are you talking about? I'll never bash F gets.
You know, it's as a friend of mine likes to say, no, I love C. I like bugs, and I don't want it to go away.
Yeah, I love C. I love my job. All right, so we see.
Let's flip over here.
Nope.
Oh.
Just hit this one right here. Just this.
Right.
Yeah, no, we have a fancy new stream setup for day 2. Jordan was here late and early, setting stuff up, moving stuff around, so we have no idea what we're working with anymore. Thank you.
I have to say it's very impressive, and I'm very bad at using it so far, but we'll get there.
It's the first match of the day. We're how many minutes in?
Yeah.
A couple.
So as our competitors are digging into it here, they're doing the standard reverse engineering. Would you want to take a look at the bracket and sort of?
Yeah, we can talk about the bracket, what we're going to see today.
Yeah. So we've got, as you can see, it's a double elimination bracket. And so this was a #1 feedback from last year, right?
Oh, absolutely. Teams were upset that they got a challenge they weren't familiar with. We didn't tell them the categories last year either, which was an oversight on our part. But you were out after one match last year. And that was absolutely, we got feedback saying this is absolutely not what we want to do. That's so unfair and stressful. So it's a double elimination bracket this year, which means a lot more work for us, but a lot more fair for the teams. And honestly, that's a good trade-off as far as we're concerned.
Yeah, and it's really good to see that because you can be really, really good. And as we said, sometimes you just notice something that your competitor doesn't, and that can get you ahead real fast.
Absolutely.
And all these players are good, so we do want to see the best player come out on top. Let's go back to
switching over to undefined. Let's see, what are they doing? Oh, see, I don't use Ghidra, so all of these UIs are new to me, but they also look like they were before my time.
Yeah, well, Ghidra, I mean, it's an impressive tool. You can do so much with it, and it is not my go-to, but their struct editor, I like the visual of the sizing going on and being able to pick out specific stuff.
Oh, that's what that is down there.
Mm-hmm.
That's nice. Yeah, I like that. I'm not stealing ideas here.
Yeah. Scoping out the competition. I got to say, though, with both Ida and Ghidra, I'm not a light theme guy. I really do prefer the dark theme.
I definitely don't appreciate having 2 monitors with light themes blasting into our eyes. It's brighter than the studio lights we have here.
It's definitely good to wake you up, though.
Oh, right. Absolutely. The coffee wasn't enough. All right, so they're still annotating structs. They're still going through. They're kind of going through the normal CTF mindset of, okay, get all of my bearings, figure out what's going on, then we look for the bug once I know what everything is.
Yeah, well, once you've got a decent bit of annotation here, I really do think that the bug's going to pop out. And this isn't just, hey, I'm going to go through and name everything. It's also they're understanding the algorithm as they name things. And so, like right now, they're looking at stir compare and thinking about, okay, what does this do? I think if you were taking this approach and you get to the target function with the stir copy, it's going to pop right out.
Oh, yeah. No, you're going to see that immediately. especially because so what is kind of this challenge? Like in a nutshell, what does the interaction flow look like? What is it supposed to be?
Yeah, so as we're seeing here, both competitors looking at these functions are talking about querying and servers. So this is an address resolution service was the sort of origin of the bug, and the CGC challenge called itself server resolution service. And so really this is about, hey, can you create a query to enumerate these instances and find things? And it's just a copying one of these fields to another in a request leads to an overflow.
Nice, yeah. So it's a fairly standard like service interaction flow, I want to say. You have creation, you have querying. I don't think you have any deletion here, so it's not going to be like a false double free or something. Oh yeah, I don't see free in the function list.
Right. I see. I'm going to flip over to Blue Water here. So it looks like they are. I see them. They just labeled something in a stir copy right there. It's funny when you see somebody and you know they're close, and you're starting to see as he's clicking around. He's looking right at the stir copy, and they're going, okay, what's that dest? Oh, he sees that it's a stack buffer. This is so exciting. I think that we're seeing. Yep, and you can
immediately back to the terminal.
When they flip back to the terminal after after that.
Check sec, no railroad, NX disabled, no canary, no pi.
I think he sees his path now.
Yeah, I think he's just like, oh my god, I spent all of that time.
Yeah, well, but also there's a lot of excitement because he's just had a breakthrough and he just wants to know how close is the other competitor.
Oh yeah, he has no idea if they've already found the bug, if they're building a ROP chain. There's no NX. I don't know why. ROP chains, there's always ROP chains when you have no NX.
I think it's just practice, and especially there's no ASLR in play.
Yeah, do you really think that's faster than just, finding one call or like pop call gadget?
Yeah, and if I recall, this one there is a friendly gadget.
Yes, there's a very friendly gadget. When I verified this challenge, I sent my solution and I looked at the source like, oh, what does this look like? And I see a comment on it saying, we left this here to be nice.
Yeah, well. Like I said, there's a little modification because we really don't want to beat the players up with things that aren't really the core bug here, and we want this to go fast.
Yeah, these challenges are meant to be solved, so the challenge is finding the bug. Yep. We might give you, an easy primitive or two to just kind of facilitate, so you don't need to search the entire binary space, binary search, if you will, and, find the right primitive to use here. We just kind of lay it out for you.
Yeah, and it's a line to walk when you're designing challenges. How easy do you want to make? What is the real challenge that you want them to solve? And in this case, it was really just finding the that stir copy, understanding what you've got on your hands, understanding the mitigations, and then writing your exploit. So,
yeah. So now they're going. Blue Water is going to be stepping through, figuring out their offsets, and starting to write their exploit. What is Undefined doing right about now?
Yeah, let's flip over and see it. It looks like they're reversing in the main function, so they're exploring sort of the switch statement that this is almost a menu sort of setup where you've got a switch statement handles the different kinds of requests, and there's not a lot, right? Originally in the CGC version, there was more stuff, and we kind of commented that out because we didn't want the competitors to have to spend all their time just sort of digging through,
Yeah. And it looks like Undefined hasn't reached the area of code with the stir copy yet.
Right, they're still labeling. They're building their understanding.
Now this might help them in the long run if they know offsets better, because it looks like Blue Water is over there calculating offsets.
Yeah, so and you can tell based on what they're looking at that they're real concerned about linked lists, which are a common source of bugs, mishandling linked lists. Not in this case, though. And I think that this is kind of an interesting thing to talk about because in the CGC you had these automated competitors that they aren't looking at the binary, right?
Yeah.
They're not reversing or annotating. They were fuzzing and doing symbolic execution, but they can cover a lot of ground, whereas our competitors here are having to manually reverse engineer and find bugs.
As good as you are, you're, at the end of the day, only one person.
That's true. I have been hoping to see somebody pull out, a fuzzer or anger, or some other extra tooling to try to overcome this.
Oh, I'm really looking forward to it. But it looks like teams are going to the basics, what they can do the fastest.
Mm-hmm.
And that looks like, GDB with whatever fancy wrapper they want to put on it, Gef or Pwnbag or PETA. Ida, Ghidra, no Benji yet. Sad. But they're going with what they know and what they've been using for the longest time.
Yeah, and I think that the discussion really is, if you have to solve something in only 20, 30 minutes, do you have time to work with something like an anger? Like, you have to be really practiced, and there's still a little, finesse involved unless it pops the answer right out.
Yeah. Well, we saw yesterday with the final match of the day that teams were racing to build ROP chains. And one team had a full layout. He had the offsets right, and everything was going right. And then Pwn Tools kept throwing like, you can't append to a relocated ROP chain. He was stuck there for 10 minutes. We had to go into sudden death.
Yeah.
And then sudden death was a ROP off again, a ROP race. And, you get these really fancy tools, but if you trip over all their bells and whistles, you might be better off with basics.
Yeah, and I think it's interesting because this isn't actually what you'd see in the real world, so to speak, right? This is a competition. This is testing, pushing people to their limits. But in a normal situation, if you were looking for bugs and trying to write an exploit, you could really take your time.
Oh, yeah. No. I mean, in daily jobs, reliability and undetectability of exploits is one thing. But CTF code is notoriously messy. Mm-hmm. It is built on a pile of commented out things that didn't work, curses, variable names that are just frustration with the author and the challenge.
Yeah, we're looking at Blue Water right now. The A's and the B's are sort of the classic visual padding. But, so far I haven't seen a lot of variable names like lol or ha or WTF, but definitely seen that before.
Yeah, a lot of maybe, a lot of underscore IDK.
Yeah.
But Blue Water is writing in their solution script undefined. It looks like
they're building out their script. So they've enumerated that, hey, there's a couple of different commands here, and they've broken down what each command type can take. So they have the idea. I don't think that they've seen the bug yet, just based on what we're looking at here. But they've got the skeleton going.
It looks like over on Blue Water, they're starting to send their BNSH shellcode.
Yeah, they look like they're pretty close.
And they're going to pack an address.
Oh, do they have their gadget?
Oh, do they? Oh, the receive buffer. Okay, so they're putting the address of the receive buffer, but do they have
no ASLR in place, so they can use the binary address?
Yeah, no
without relocation.
No, nothing.
Or rebasing.
But do they have the gadget? Because, you know what? They might just put it on top of the stack, and then a red will get to it, or leave. I'm not sure exactly.
I think we're seeing them. I think they're still exploring here, but they're pretty close.
Oh yeah. Okay, they're going back. They're double checking their offsets. They're making sure they're in the right function here. Okay, and then they have a jump, and they're like, but the leave should load it. It should work. So setting a breakpoint, walking through.
Yeah, and he knows he's so close, right? This is the tense, almost to the finish line. Just got to figure this last bit out.
It looks like he's going to hard code the stack, which will work fine in local execution GDB, but stack address not fixed.
Yeah. Stack address is not as not your reliable binary gadget here.
Yeah, no, it is not built into the binary. It is not affected by pi. Well, I'm sure it is in some way or another. Size. Okay, so we see the first meme variable name. All right, so they're building out shellcode. Yeah, this is starting to look like the code that I wrote to solve this. Building out padding correctly, making sure everything lines up properly. And walking through, they're going to get seg faults here, but they're going to know where exactly in their chain they're seg faulting. It'll give them a better idea where to hone in on that offset.
Yeah, and some of this really is just that iterative try one thing, see where we're at. Maybe a missed assumption or things just.
Yeah, here we go. So top of the stack is the address of the receive buffer.
Mm-hmm.
And then it looks like the shellcode isn't being written properly. Oh, nope. I saw a push x68.
Okay.
That looks promising.
The SBB, the add, that doesn't look like the shellcode, but looks like they're landing something.
Yeah, they're definitely somewhere. They're almost there. Over on undefined, let's see what's going on. Python solved up high. Okay, so they're printing out receipt packet information. They're still writing an interaction here. Do they have the query 1 implemented yet? I can't see quite that far.
They have a function written to do the query 1. I'm not sure that I've seen them bring that up though. In terms of looking at it in Ghidra and finding.
Oh, they're going really in depth in the query all.
Yeah, they're going a little deep on the reverse engineering, and it may cost them because the bug isn't. It's not too complicated in this case. But we're seeing them. They're giving it everything they got. They're frantically looking through. I think the speed that they work at is impressive, but you can also, I think, at this point start to sense a little desperation. Like I'm sure that they're feeling, where is the bug? Where is the bug?
Yeah, they're looking through. They're getting a really solid understanding of the binary, but they're missing shallow bugs looking for deep ones.
Okay, so hint number 1 just dropped. So the hints are set up to drop.
Let's see, what is hint number 1? This is a classic old school bug. What a helpful hint, Mark.
Well, thanks, Josh. Thanks. So when I think of old school bugs, I think of string bugs. I don't know about you.
Fair.
So string handling bugs. I'm looking at.
Stack buffer overflow too.
Like yeah, stack buffer overflow.
Okay, it is a helpful hint.
I'm not thinking linked list. I'm not thinking heap.
It's not an IOU ring bug.
there's a stack buffer overflow somewhere, and for me, I'm looking at stir copy, stircat.
Yeah.
Hoping something like that.
Any of the classic overflow vectors.
Right. Now, for all of these challenges, we're doing it to try to set them on the right track in case, especially a case like this where, maybe they're just looking in the wrong spot, and so hint number 1 is to try to guide them towards the right spot, and then hint number 2 is like, okay, here it is, just do this.
Yeah, hints released at 20, 35 minutes, 50 minutes we go into sudden death.
Right.
We're setting a hard cutoff on that this year. We made the mistake last year being too lenient with it. But it looks like we're 15, 18 minutes in, somewhere in there.
Yeah, and really looking at.
Or no, we're past 20 because I'm on.
That's right. Hint drop. Hint drops automatically this go around, which is a nice bit of automation. We're not completely beyond the setting pieces of paper down in front of the competitors, but
that is how they connect to the challenge server. Yeah. But going through, okay, so Blue Water is going through making sure they're on the right path, or are they looking for another vector? Or are they just checking offsets?
Well, the hint, and I saw both competitors look at the hint, and it says it's an old school bug. They've got a stack buffer overflow. I think that they're just trying to break down, how do I get to my shellcode at this point? Yep, looking at gadgets.
Yeah. Oh, my.
Yeah, that's some some ANSI color sequences there.
See, that made me
good
ANSI.
Old kick.
Okay, so we're looking for sub RSPs, right?
Okay, that's the road they're going. I think that there is a call register.
There is a pop EDI, call EDI or something.
Yeah.
RDI.
Yep.
It's not that old school.
Trying to make it easier. And so if you have that kind of tool and you're grepping for a call or a jump gadget, it should just pop out at you.
Well, absolutely, but he's looking for what he knows. He's looking for classic.
That's right. And if you're used to working on modern exploitation challenges, they're not this easy. You have to do a little more, and so they're probably not expecting it as easy of a challenge. So hopefully, as the tournament goes on, we'll see a little bit of that. Okay, check for the easy thing first, and then maybe.
Yeah, this is a live CTF. We do want you to solve it. Mm-hmm. We really want you to solve it. All right, so it looks like just building a manual payload here instead of using like Pwn Tools Shellcraft. Or maybe he'll still use it. Who knows?
I think it looks like he's.
Oh, he's just figuring out the offsets again.
Yep. Playing with the padding, trying to understand what exactly. Maybe looking for a leak.
Yeah.
They're looking at the output there, seeing what the server sent them. And there's a lot of junk. It's all
There's a
randomized.
lot.
Again, this was this challenge was built to be run in a different environment where randomization was handled differently. These were automated competitors. They're not reading the output, so
No.
it is.
It threw me off a little
garbage.
bit when I was parsing output, and I just got random strings back, and I'm like, am I parsing this right? Is it like 7-bit UTF?
Yep.
But no, it's just completely random strings. Printable strings. That's important.
Right. Right.
Yeah, that would be mean if we just throw like a null byte in there. They parse it out and early.
So let's switch over to undefined. It looks like I have to imagine that's their overflow that they're playing with all those A's.
Yeah, it looks like they're stepping through, figuring out where in all those A's they are.
And I gotta say, I'm loving their debugger setup here.
So they're in parse query, it looks
Okay.
like, not step fully into the query one. Oh no, parse query has a stir copy, doesn't it? Or is it in query one? I forget.
I believe it's query 1. In parse query, I think they're looking
Oh,
at
yeah, it's in
the
query
string
one.
handling to try to. They've got an idea that this is an overflow. So that hint looks like it did give them a little bit of an
Yeah,
idea.
okay, it was a good hint.
That
You're
they're
absolutely
looking
right.
for overflows up, seeing some comments go down, tracking, hey, what are the maximum lengths that can be sent in different places? And so what that was the parse query, which populates a larger buffer, and then the query 1 buffer is a stack buffer, which is smaller. So they're on the right path. They're looking for that. Now we see them looking at a stir copy.
Oh.
So they're thinking, hey, is this a stir copy bug, stack overflow? Right, kind of thinking.
The wrong stir copy.
That stir copy there is an innocuous one.
Yeah.
You can totally use it safely with enough checks or static string buffers. But if they were to look at the cross references on string copy, that
Ooh.
would drop them right in the right spot.
They would. So let's see. Going into.
So this is
Where is
the receive until. So
Ah.
just helpful wrappers around the receive function. Again, this was built in the CGC. There's a fair bit of scaffolding in play
Yeah.
that they had. They had their own libc. So the challenge authors then built familiar wrappers commonly to make the challenges look like what we'd expect. But this is, I think, the competitor trying to understand, okay, what are the limits? How much exactly is going to be written in that buffer? Okay, we see the buffer label, the size is right next to it.
Oh, but over on Blue Water, they have RBP 414141.
All right, so when we see register control, we know we're close, because really in this case, building a stack buffer overflow, there's only a few steps, right?
Yeah.
So you've got your overflow. You understand, okay, what registers do I control? What are the offsets to control those registers? And then what should I put in each of those? And what's going to be the easiest way to get shellcode running?
Now, what I'm worried about with Blue Water is they were returning, I think, to the receive buffer, which I think is in BSS.
Oh.
So I'm not sure that that's executable, like, unless you protect it.
Well,
But that might have just been where they're putting their return address and they pop it and read to stack.
Mm-hmm.
I'm not 100%.
I did see them looking at the virtual memory map. So they were looking at permissions for readable, writable, etc.
Hopefully, yeah. I mean, we don't know what's going through their heads. They could be thinking anything right now.
Yep.
He could be thinking, man, this would just be so much easier if I can get, a UAF in here.
Yeah. Their mind may still be on the DEF CON CTF finals, right? Maybe they've been working on another challenge, and this is just total whiplash in terms of.
Yeah, Blue Water sat down, was asked, like, can I unplug from HDMI so I can keep working on the challenge I was working on?
Love that dedication.
We're like, yeah, go for it. Like, we're going live in a couple minutes, and he's like, unplug, keep working on the challenge. I go over, and I'm like, we're going live soon. He's like, okay, cool. Plug it back in, close everything down so no other team can see what's going on.
Awesome.
We don't want to leak any, main, DEF CON CTF challenge solution progress, anything about that.
Yeah, it's definitely the case where the competitors know that their screens are being streamed.
Yes. We are very explicit telling them that. We don't want anyone leaking anything. No password managers pulled up and they're like, oh, yeah, what's my password again? Pull it up on screen. RBP. Oh, okay, so it looks like he is the offset, right? RBP is B's now.
Okay, yep. So he's nailed that offset, and now just determining, okay, where do I go from here? What's the gadget I want? Can I do something with RBP?
Man, it sure would be great if I had a DREF RSP plus 32, call.
I'm just waiting for him to go back to his gadgets file and look for some friendlier gadgets.
Yeah, you can make do with what he's found so far, but it is not going to be fast. You need that nice gadget to just kind of expedite the entire process, or maybe he'll jump back, call some puts, call printf, and get a stack leak, do it that way.
Yeah, and I never count these competitors out. I fully expect when I write a challenge like this that they are going to come up with some way to solve it that I didn't expect.
Absolutely. I mean, we've seen that in a couple challenges yesterday. They were close to intended, but they did, they diverged from the path that we kind of cut for them, that we put in place for them. And I think that really says that these competitors are all experts in the field. They understand these things so well that they can go around. They don't need to walk the path that we kind of laid out for them. They see something off to the side, traverse that, and it might end up being faster, might end up being slower, but it'll work in the end. As I say that they're experts, what does the leave instruction do?
Look, but this is real.
Honestly, it's totally
every
fair.
Expert
I'm just
uses
throwing,
Stack Overflow. Tell me you don't. Tell me you don't, Josh.
I can't. Well, I could. I'd be lying. But no, we saw yesterday, we had man7.org and Stack Overflow, and I don't know which one is better as far as describing what things do.
Let's take a look. I think on the undefined side here, he's in the right function. He's got his cursor on stir copy. I think that we're watching him live understand. So he's got the instance buffer, the stack buffer labeled as instance.
He's highlighting the stir
copy.
Like,
this is the destination.
He's like, how big can this be again?
This is the destination. Yep.
Wait, this
query
is such a small buffer.
Yep.
No, he walked over it. I'm not sure if he just counted out because there was an innocuous one earlier, and it just kind of blends into the background. Or if he saw it and he's just marking stuff around it so he knows what's going on after.
Yeah, perhaps looking for something afterwards that might modify or otherwise change the environment. But the query arg, query being the argument to the query1 function, that is a little bit of a hint that, hey, if he can go back and understand what part of that structure he controls, I mean, he's looking right at it. So I think we're seeing...
Yeah, rewriting to use the query1, it looks like.
Yep. So this competitor is understanding, okay, we've got structures in terms of server name, instance name, and then on the right path.
You know what I'm seeing a lack of? It's type hints in their solve scripts. It is honestly underrated. The number of times I pass a string to a function that takes bytes and the encoding gets messed up, or it passes and Pwn Tools throws a warning that I'm not aware of. UTF fucks everything up. Like, really, type hints and exploit scripts have saved me so many debugging steps.
Oh yeah, I mean the only time in the past year or two that I have written Python without type hints was writing a challenge for this.
Yeah.
Because I didn't want people to figure it out too quickly.
Yeah.
All right, let's take a look and switch over to Blue Water.
All right, Blue Water, looks like they're going in the parse query, looking at the calc lengths. I think they haven't seen the nice gadget yet.
Yep, I agree. I think that there's they might have a technique in mind.
Yeah, so it's hanging. I wonder if they're just going to run it against and wait for the stack to line up at some nice boundary or something. I'm not 100% sure.
Oh, it looks like they're exploring the other functionality in there. So if I recall, there's only 3 or 4 different things you can get the target to do. So
yeah, it's a smaller surface.
Perhaps there's something hidden in the other functions that he wants to use or thinks that might be helpful in terms of.
Yeah. Now, looking at decompilation, you're not going to see those nice gadgets hidden in there because they're just going to be optimized out in some cases. They're in dead code. They could be just unoptimized. Decompiler throws them away because it's an if false.
Right, exactly. And I think that that's the case with this specific gadget. It was inserted to make life easier, but it's really not in the hot path. You know, it's not something that you're going to run into just running the binary.
Yeah, and that kind of brings up one of the major downsides of only looking at decompilation is you're looking at this output where all these heuristics, especially in IDA, all these heuristics were being applied that removes things you're not interested in for actual functionality. But when you're getting down to the actual creation of an exploit, you really need to look at the fine-grained, you know, I have a sub-RSP32 call. Like,
Right.
I have all of these things in dead paths that I can use. And we saw him looking at ROP gadgets for, you know, a minute maybe.
Mm-hmm.
But he was just searching through for sub-ESPs.
Yeah. I think that there's a tendency to go with what you know, and I don't think that Magic Gadget is going to work on this one, right? So it's like, all right, what's the fallback here? And that can be challenging if you know you're not prepared for it, you're not expecting it.
I'm wondering if now he's trying to get a libc leak or something, and like, oh, I'll just one gadget it, something like that. But just as easily, there's no NX. You can get a stack leak and jump to it.
Mm-hmm. Yeah, I think that at this point there's it feels like this is one of those parts in the pattern of writing an exploit that automation would help, you know? Like, suggest a few things. Because as you said, there's a lot of trust in the tools. Decompilation, a great example. You're counting on the tool to show you exactly what's there. And I think that walking that line of using tools to make you faster and make things that are hard easier is something that I only expect to see more of in the future.
Yeah. And we see over on Blue Water, they just highlighted the RWX stack. I don't think they noticed.
Oh, we're back.
We're back in the gadgets. Okay. But at the same time, Undefined was writing their solve script too. In their solve script, they have hard-coded binary data, so it looks like they're just fine-tuning. They're going through with a fine comb now, figuring out where it goes wrong.
Yep,
Oh, they have
overflow.
ret to... Is that controlled address? I can't see that far.
Yeah, we've got RSP. They control RSP, and you can see the cyclic pattern is going to allow them to calculate exactly what the offset is.
Oh, that's what that was. They were just pasting cyclic output, maybe.
Mm-hmm.
Yeah, so now they're going through and actually...
And so this is a clever point because even it's not just, hey, okay, so you can see that they're putting a known value that's going to go in the return address, but then after that, seeing, okay, which of these other values ends up in other registers. So you can understand, hey, each register that I control, this is exactly the offset that's going into it.
Oh, yeah. And it looks like, is that dead beef I see over there?
Mm-hmm. So they've definitely landed the return address override, and now let's see what their strategy to get execution is.
All right, so are they going to look through gadgets? Are they going to see any nice leak there? Not 100%. It's never guaranteed. You can be so close to the solution and then overlook one thing, one nice gadget, one win function. And hint 2 just came out.
I saw somebody checking the LiveCTF page to see if that hint had dropped. And I think that we added a timer today so that competitors could see exactly how close they were to getting a hint.
That, I was told, was not 100% not going to break the infra.
Well,
so I did not deploy it for first match.
Oh, okay.
But I told them in person, check back at this time and this time. There will be hints. Refresh the page. But they might be a little too focused on this. They might not notice it.
Outstanding. Yeah, the priority is that the infrastructure actually works. So
I was not about. I waited in line for breakfast, came over here a couple minutes before, plug everything in, please work, please work. IP tables routed everything properly. Containers started. I'm like, yes. So undefined. Hang on, no arch present. Are they? Oh.
I think we're seeing a.
Yeah, we're seeing a ret to the receive buffer again.
And so they're working through. They've got the overwrite. They know that they've got the bug. They're just trying to finish out. And honestly, Blue Water, if we flip over them, they're looking through gadgets. They know that they've been closed for a long time.
They see that pop RBP ret, which is pretty nice.
Yep.
But that doesn't give them the stack offset.
Yep. Yeah. So at this point, really,
they're just going with full ROP chain.
Well, and that's an option. If you,
I don't know if it is. because there's no system call in this. There's no I guess if you get lucky and find the syscall right? That's what it comes down to. But I don't know if there are any raw syscalls in this.
Good point. I think, but it's with an overwrite there like this. There's a few things you can do. If I recall, it's not null terminated, so you can write.
Oh.
I want to say it's new.
That's
no,
pretty
it's
nice.
a stir copy, so it is.
Oh yeah. Okay, but you can have null-free shellcode pretty easily. That's not too bad of a constraint. Let's see. So they're getting the offset right. Oh no, you don't. No, I mean if they're writing a ROP chain, you can just fully ROP to it and probably build binsh that way because you have address of the receive buffer. You can just send binsh in it. Yeah,
that's right. You've got a larger buffer that you could stage stuff.
So they actually.
And it looks like that's what they're trying to do.
Ooh, I hope so. Where is that? Yeah. So they have padded shellcode on there. They're putting ROP gadgets after, which are going to be on top of the stack and hopefully ret to it.
And that makes sense with the other, when they were looking at the other functions. I think that they might have been trying to send data to get it staged somewhere else and then maybe look for references to that data later.
Yeah, but it looks like also that they're sending 7 A's instead of 8, so they still have that leading FD on top of the stack. So I'm not sure if they see that or if they just see the A's at the end. They're like, okay, cool, I'm overriding everything. Yeah, they see a rex.b. I don't think that's part of their shellcode.
Just wanted to point out, undefined, pulling out the check sec, understanding that there's no mitigations in play. They're looking for how do I get execution? Got the stir copy.
They have stir copy. We saw them get rip. They got rip once at Dead Beef.
Okay, so what we're seeing here is looking at ROP gadgets and.
Oh yeah.
So this is.
And they're looking for RSP gadgets.
Yep.
Which is on the right path. It's close.
Yeah, parsing these outputs, that wall of text, it's always tough for me. I always feel like there's got to be a better way.
Oh, this is a tool I haven't seen before on Blue Water. disasm.will.gl. Oh, this is nice. It's like a nicer diffuse CA, honestly. Diffuse CA is something I go to for just like in-browser disassembly assembly. I just want to copy a bunch of bytes out.
Yeah, having little tools like that it's really helpful. And in competitions like this, really having a number of tools to go to is helpful. You want to have all the tools in your toolbox that you could possibly need because you never know what's going to come up for a challenge.
Yeah. Oh, and it looks like, okay, so he's looking now, what opcodes can I use that start with OX3, the command code in the packet, to get to this path? Oh, they're both so close. I just heard mumbles of sudden death. I'm not sure when we're getting there, but I imagine we're getting close. 10 minutes? 8 minutes to sudden death.
Wow.
Sudden death, an easier challenge, should be solved fairly quickly.
Mm-hmm.
We did not write all of them last night, but I verified all of them and they work. Very easy challenges, very fast, does not require this level of either reverse engineering or this kind of these exploitation chops, I guess.
Yeah, and really hoping to see a solve for this, especially because I feel for the competitors. Been there, you're so close, and you hate to go into sudden death when you're just minutes away from a solve.
Yeah, but it looks like over on Blue Water, they're trying to read from an invalid address, and that really looks like just random data on the stack. They're reading to what's in their RBP. Oh, they're scrolling so fast. Oh, RBP is argv0. Or a pointer to argv0, so they're too far down the stack. Okay.
Sometimes it just becomes a challenge to follow the thought process because these competitors are so fast.
Oh, and they have 5 different threads going at once.
Yep, they're trying different ideas, seeing what sticks.
Yeah. And really, we give a general category of what the challenge is. So I think this one was old school pwn as the hint or something like that, or as the category we give the competitors. So outside of that, they don't have anything. They don't know whether to send, the guy that wrote House of Blue 42 or whatever.
Yeah, there's we try to set them up this go around with information at least categorical, so that they can say, hey, you're better at heap challenges, you're better at stack challenges. And we see that second.
Okay. The second hint, query 1 uses stir copy,
Yep.
was the hint. Both competitors already there.
Already knew that, yeah.
So I don't think hint 2 is going to be that helpful. I mean, really, at this point, they have everything they need. We're not going to say, oh yeah, this gadget is at this offset. That's so incredibly free. They need to know what they're looking for. They need to have an idea of what they need next in the exploit chain. But it looks like they're getting hung up on kind of, how do I get a leak?
True. I mean, yes, we could have put the hint as like maybe this gadget would be helpful, and I think that both of these competitors honestly would really appreciate that right now.
Oh, absolutely.
Then it would just be a race to see who can type in that address faster.
It's just monkey type at that point.
I think on the undefined side, we're seeing some pwn tools use that they're resolving symbols to get those addresses automatically. I think that's I love to see the power users of libraries, frameworks, tools, and see how they can make their lives easier. Because I really feel like that should be faster, right?
Oh, yeah. No, pwn tools has a lot of great bells and whistles on it. And it has a lot of great functionality for mundane tasks. Like calculating offsets, working from a base. You don't need to have some libc base variable in there. You can just load the elf, set base address once, and then work relative to that with symbols. It's really nice.
Yeah, and this Rob Gadget interaction that they're doing is very cool. I don't think I've seen this tool.
Yeah. So what tool are they using? I can't read their very dark font.
Lin, X64.
Oh.
Could be a custom tool.
Oh, could be. I'm a fan of like Ropper. Rop Gadget is a classic.
Well, I think actually what we were seeing was a grep output that they could scroll through and highlight lines, which was...
Yeah, we have, or we had an RPI sec, a tool called Grepper, GREPR, that would do ROP gadget search and then provide a nice live filterable view of all the gadgets, and you can use like regexes in there. It's really nice.
Yeah, stuff like that. I mean, it seems simple, but you put enough of these simple tools, put them together, and it makes your life easier, which equates to a faster solve.
Hopefully it does, because we see so close. We see blue.
Prepping for pop.
Oh, wait. All right, so they're looking for pops still.
Yeah.
Over on Blue Water, we also saw them looking at that pop RBP ret call, or gadget again.
Yeah, they're both looking for that.
Yeah, but
because they've got control over RBP.
That's going to put them maybe in some random invalid address because there's just data after that before their buffer. They really need that stack ink or deck. I forget which one it is. I think it's ink.
Yeah, and this is tough because you never know what exactly is going to be the gadget that's going to do it for you going in, and everything's easy to look at in retrospect, right?
Oh, yeah. No, CTF is a lot about making do with what you have. And you can easily accept that all you have are the gadgets in the binary. There aren't any nice ones there. But at least take a cursory look. Oh, move Rax RSP. Add Rax. Ooh.
See?
Okay, he found the nice gadget. 4019 FD.
My favorite address.
It's up there in me. It's like, it's in the top 4 billion, I want to say.
Yeah, roughly.
Roughly.
And so
at least in 32-bit.
And this is exactly what we talked about. They're going back to the gadgets, finding the thing that's going to make their life easier, and I think at this point it's just a matter of time.
Oh, yeah. So it looks like Blue Water found the nice gadget they're working through. That pop is going to take them exactly to the beginning of their overflow. So it should just be as simple as inserting shellcode after that.
Almost like it was made that way.
Imagine.
All right, let's take a look at undefined. They looking through stack addresses here, trying to understand what they control, what this pointer specifically is looking at. You know, the pop, ret kind of gadgets. They're looking to see if that's useful for them.
They are. And then over on blue water, they're on the stack.
And I see that.
I see push OX3B syscall. They walk through it. They just have registers set up wrong, it looks like. I couldn't see quite in time. So they might just have offset 1. Might be missing the first instruction in that chain. Could just be a XOR of some, like RCX or something.
Yeah, I saw that they were using the Pwn tools built-in shellcode. So probably not any mistakes there.
No, it's very thorough. It's verbose.
But making sure that that came through untouched, you know, completely valid. That looks like what they're doing there.
Yeah, I don't know if Pwn tool shellcode actually has null bytes in it. It might have null bytes, which would really break this flow here because it would stop reading the string. But no, it got to the syscall, so it can have null bytes in there.
Yeah. So there's the call. He's looking at this.
All right. Oh yeah, that's move ESP EDI ref RSP.
Probably doesn't want that at the beginning of his shellcode. Does he?
I don't know.
Oh, and I just got word that we're heading to sudden death. Oh, that is.
We're heading to sudden death.
He's
no,
so
he's on his shellcode.
Oh gosh.
No. Oh, don't save the database. You can feel it. That's so upsetting. Oh, he's deleting the challenge.
Oh, I can.
Oh, that's so sad. He was walking through his shellcode.
So.
But we mentioned, I made sure to mention 50 minutes. We're going to sudden death. That is so sad.
So we're having some technical difficulties with the camera here on our end, but.
So we're just going to stay on bracket view for a bit. I don't know which way this is going to go. Undefined was working slowly through it. They were about to find the gadget, I'm sure. Blue Water just found it.
They were just looking through gadgets again. Man.
Oh, that's.
You know that.
It wasn't guaranteed to go one way or another because Blue Water was just starting to debug where they were jumping to.
I think that they were very close.
You saw them highlighting the first instruction in their payload, and it was just, as far as I know, bad. It was just a bad instruction. Well, not bad instruction, but it was bad instruction to have in your payload.
Yeah,
it wasn't the right instruction.